free fall and the acceleration of gravity. Now, the classic story of your science or physics teacher taking two objects of different masses and dropping them. Before dropping them, your teacher would generally ask the class what they would think would happen. Some students may say the heavier object will hit the ground first, and some may say they both touch the ground at the same time. Once this experiment is conducted, it can be seen that the super smart child in the classroom that has been obsessed with physics, or perhaps the students that have read ahead, appear to have the right answers. Both objects touch the ground at the same time. The question most people cannot answer is why. This leads into, do they have the same gravitational pull, and do they fall at a constant speed? Some say they do. However, physics shows that even though the objects land at the same time, their speed constantly changes. As well as, depending on the object's weight, it changes the gravitational pull of the object. This can be represented by the equation gravity equals mass times acceleration, or the acceleration can be represented by 9.8 meters per second squared. So now that we know that objects of different weights can land at the same time, then why do some objects fall faster than others? The answer is drag. As shown by the equation, Fd, or the force of drag, is equal to half of cp(a)v squared, where p is the density of air, and a is the cross-sectional area which is exposed to the wind, and v is the speed of the object, and c describes what is called the drag coefficient. The greater the surface area, the sooner the object will remain in terminal velocity. So for instance, a shuttle would reach a terminal velocity before a rock. And finally, the larger the drag, the longer it takes for the object to reach terminal velocity. For instance, a rock would reach it before a pebble. Now back to a bit more broad perspective on falling objects. Any object that falls from a height on Earth accelerates towards the ground at 9.8 meters per second squared, which means for every second the object is in the air and falling, it will speed up by 9.8 meters per second. But there is an end to where the object stops accelerating. This endpoint is called terminal velocity. It occurs because when an object is moving through the air, it runs into air particles, which then creates drag, as you learned earlier in this video, how drag affects the speed of the object. But the neat thing is that every object has a point in which the force of drag is equal to the force of the object when it's falling. So that means that at that point, the object would stop accelerating, aka reaching its terminal velocity.